Okay, so in last class I discussed the solution of discrete time state equation. That means according from the previous classes, it is in the if the solution of continuous time state space equation, it is x dot is equal to x plus bu and output equation yt is equal to cx plus du. Then the solution of state variable xt is equal to e to the power at x naught plus integration from 0 to t e to the power a t minus tau b u tau, and e to the power a t is equal to inverse Laplace of si minus a inverse is called state transition matrix. Okay, so similarly now we have to find out the solution of discrete time state equation. So in discrete time state equation are xk plus 1 is equal to g xk plus h uk, and yk, that means the output equation, is equal to c xk plus d uk. Almost similar to the continuous time domain, that is g is equivalent to a, b, h is equivalent to b, and c is equivalent to c, and d is equivalent to d. So from the normal way, that means from the recurrence method, the solution of state variable xk is equal to g to the power k x0 plus summation start from j to the power j is equal to 0 to k to the power minus 1 g k minus j minus 1 h uj, and the output equation is equal to c gk x0 plus c summation start from j is equal to 0 to k minus 1 g k minus j minus 1 h uj plus d uk. Okay, so if you compare the solution of discrete time state variable with continuous time state variable, so they are almost similar to each other. That means state transition matrix in case of continuous time domain is equal to e to the power at, and in this discrete time variable state equation, state transition matrix is equal to g to the power k. Now in the second part, due to input force, there is a integration from 0 to infinity e to the power a t minus tau b u t tau into d tau. So here integration is replaced by summation. That means summation start from j equal to 0 to k minus 1 g k minus j minus 1 h uj. Okay, so the second approach for the solution of discrete state equation is called jet transform method. So you know the state variable of discrete time system, it is xk plus 1 is equal to g xk plus h uk. If you apply jet transform, then it becomes z into xz minus z into x0 is equal to gxz plus h uz, where xz is the jet transform of xk, uz is the jet transform of input. So finally, if you rearrange the expression, then xz is equal to zi minus g to the power minus 1. That means inverse of zi minus g into z x naught plus zi minus g to the power minus 1 h into uz. Okay, now if you take the inverse Laplace inverse jet transform of the given equation, then the solution of state variable, that is xk is equal to inverse jet transform, that is xk is equal to inverse jet transform of zi minus g minus 1 z x naught plus inverse Z transform of Zi minus G inverse H into Uz. So now, now if you compare with the previous expression of the solution, that is Gk is replaced by Z to the power minus 1, that is the inverse Z transform of Zi minus G inverse Z, that is the Z inverse of Z inverse of Z inverse of Zi minus G to the power minus 1 into Z. So you can say that the transaction matrix of discrete state is discrete state equation, it becomes G to the power K or Z inverse of Zi minus G to the power minus 1 into Z. And that is summation portion, that is J is equal to 0 to K minus 1, G K minus J minus 1 H into Uz is replaced by Z inverse of Z inverse of Zi minus G minus 1 minus 1 H into Uz. Okay. Okay. So any problem? So that means solution of discrete state variable equation is equal to Z inverse of Zi minus 1, sorry, inverse Z transform of Zi minus G inverse into Z into X naught plus inverse Z transform of Zi minus 1 to the power minus 1 S into Uz. Okay. So now we have to solve one problem so that you can understand the solution, how to have to find the solution of state variable equation. Now, problem number 1. Okay, one problem based on, so obtain the state transaction matrix and the solution for the given system. Suppose you have one state variable, discrete state variable x1 plus k plus 1 is equal to g xk plus h uk yk is equal to c xk. Okay, where g is equal to 0, 1 minus 0.16 minus 1, h is equal to 1 1 and C matrix is equal to 1 0, and the initial value of the state variable is equal to x1 0 x2 0 is equal to the value of two state variable is equal to 1 and minus 1. Now we have to find out the state transaction matrix and uh, and the solution of state variable. Okay, so what is the formula of state transaction matrix in discrete time domain? What is the formula of state transaction matrix in discrete time system? That is the solution or state transaction matrix. State transaction matrix is equal to G to the power K or Z inverse, sorry, inverse Z transform of Zi minus G inverse into Z. Yes or no? Yes or no? And please tell me what is the what is the formula of state transition matrix in continuous time domain? What is the formula of state transition matrix in continuous time domain? In continuous time domain, formula of state transition matrix is equal to inverse Laplace of Si minus A inverse. Yes or no? So if you compare with the discrete time system, in discrete time system, state transition matrix is equal to inverse inverse Z transform of Z I. What is I? I is a unity matrix minus G to the power minus 1 into Z. There is one extra term is in the discrete time system is Z. I am audible to you?
Yes,
Hello?
sir. Yes, sir.
Yes, sir.
Okay, now we have to find out the first you have to find out the Z I minus G matrix. So what is the order of G matrix? What is the order of G matrix? 2 into 2. So unit matrix must have the size 2 into 2, that is Z into unit matrix 1 0 0 1 minus G. So G matrix is equal to 0 1 minus 0.16 minus 1. Okay, so it becomes Z minus 1 0.16 Z plus 1. Okay, now we have to find out the inverse of Zi minus G matrix. Okay, so from the inverse of the matrix, you know what is the formula of inverse of the matrix? Adjoint of Zi minus G matrix divided by magnitude of or determinant magnitude of Zi minus G matrix. Yes or no? Yes or no?
Yes, sir.
Okay. So now we have to find out the magnitude of Zi. First, we have to find out the magnitude of Zi minus G matrix, that is equal to Z into Z plus 1 plus 1 plus 0.16, that is equal to Z square plus Z plus 0.16. Any doubt?
No, sir.
Okay, so if you factorize it becomes Z plus 0.2 into Z plus 0.8. Okay, so now we have to find out the adjoint of this matrix. What do you mean by adjoint of the matrix? Transpose of cofactor matrix. Yes or no?
Yes,
Transpose
sir.
of cofactor matrix. So what is the cofactor of Z? That is equal to Z plus 1 and minus 0.16, again minus plus 1 and Z. Now we have to take the transpose divided by modulus of Z minus G. So this transpose becomes Z plus 1 minus 0.16 and Z. Yes or no? Yes or no?
Yes. Yes, sir.
Divided by Z plus 0.2 into Z plus 0.8. Okay. Okay.
Yes, sir.
Okay. Now that is z I minus g to the power minus 1, that is inverse of z is equal to z plus 1 by z plus 0.2 plus 1 by, just wait, and second element 0.2 into z plus 0.8, and in denominator 0.16 by z plus 0.2. Okay, and z plus 0.8, and fourth element z by z plus 0.2 into z plus 0.8. Okay, now what do you mean by state transition matrix? Formula of state transition matrix. So formula of state transition matrix is inverse z transform of z I minus g to the power minus 1 into z. So we have to multiply term z with this, so z I minus g inverse into z is equal to z into z plus 1 divided by z plus 0.2 and z plus 0.8, z by z plus 0.2 into z plus 0.8 minus 0.16 z by z plus 0.2 and z plus 0.8 and z by z square by z plus 0.2 into z plus 0.8. Okay, now we have to find out inverse z transform of z minus z I minus g, inverse z transform of z I minus g to the power minus 1, that is inverse into z, that is we have to find out the inverse z transform of this matrix, that is equal to state transition matrix of the given problem. So how you can find, we have to find out the inverse z transform of each factor, each term. How you can find out? Please calculate and tell me the z inverse of z into z plus 1 divided by z plus 0.2 into z plus 0.8. जल्दी से बताओ. Hello. Hello. Am I audible?
Yes, sir.
So first term of the matrix is equal to, you have to find out the z inverse of z into z plus 1 divided by z plus 0.2 into z plus 0.8. Okay. Hello.
Yes, sir.
तो क्या आएगा जल्दी बताओ.
इसमें सर -4/15 सर ए का वैल्यू सर प्रांशल फ्रैक्शन करेंगे तो सर ए का वैल्यू 4/15 है सर, -4/15.
सो यहाँ पर दो फैक्टर आएगा. 4 by 3 z by z plus 0.2 and minus 1 by 3 z by z plus 0.8. इसका inverse z transform and it becomes जो वैल्यू आएगा 4 by 3 z by z plus 0.2 इक्वल टू हो जाएगा माइनस 0.2 टू द पावर k। ये तुम्हारा a टू द पावर k का जो z ट्रांसफॉर्म होता है वो क्या होता है z by z plus a and minus 1 by 3 minus 0.8 टू द पावर k। ओके, सो सेकेंड टर्म हमारे पास क्या है? सेकेंड टर्म क्या था? z स्क्वायर बाय z प्लस 0.2 इंटू z प्लस 0.8। सो जब इसको ब्रेक करोगे इसका z ट्रांसफॉर्म इनवर्स z ट्रांसफॉर्म निकालना पड़ेगा। सो इसका इनवर्स z ट्रांसफॉर्म में जब इसका फैक्टर करोगे तो दो फैक्टर आएगा 5 by 3 z by z प्लस 0.2 माइनस 5 by 3 z by z प्लस 0.8। सो अगेन इसका वैल्यू कितना आ जाएगा 5 by 3 माइनस 0.2 टू द पावर k माइनस 5 by 3 माइनस 0.8 टू द पावर k। ओके, सो फाइनली थर्ड टर्म क्या है हमारे पास? थर्ड टर्म था माइनस 0.16 z बाय z प्लस 0.2 इंटू z प्लस 0.8। so inverse z transform of given factor have two factor. First factor is minus 0.8 by 3 into z by z plus 0.2 plus 0.8 by 3 into z by z plus 0.8 z inverse. So it becomes minus 0.8 by 3 into minus 0.2 to the power k plus 0.8 by 3 minus 0.8 to the power k. Okay, and the fourth term is you have to find out the inverse z transform of fourth term. That is fourth term क्या था हमारे पास? Fourth term is z square, sorry second term only z था, sorry, and z square by z plus 0.2 into z plus 0.8। सो इसका जो फैक्टर होगा वो आएगा इनवर्स z ट्रांसफॉर्म जो है उसका जो फैक्टर आएगा वो आएगा माइनस 1 by 3 z by z plus 0.2 प्लस 4 by 3 z by z plus 0.8। ओके, सो फाइनली इसका जो वैल्यू आएगा वो माइनस 1 by 3 माइनस 0.2 टू द पावर k प्लस 4 by 3 minus 0.8 to the power k. Okay, so that means in this problem state transition matrix becomes first term 4 by 3 minus 0.2 to the power k minus 1 by 3 minus 0.8 to the power k. Second term 5 by 3 minus 0.2 to the power k minus 5 by 3 minus 0.8 to the power k. Third term minus 0.8 by 3 minus 0.2 to the power k plus 0.8 to the by 3 minus 0.8 to the power k. Fourth term -1/3 minus 0.1 k plus 4/3 minus 0.8 to the power 0. So any doubt in the solution of state transition matrix?
ये सर
Hello?
कैसे सर एक्सप्लेन किया सर? पार्शियल फ्रैक्शन सर नहीं समझ में आया सर, कैसे किया सर वो?
पार्शियल फ्रैक्शन जो है कैसे क्या, ये समझ में नहीं आया। पार्शियल फ्रैक्शन में हमारे पास दो फैक्टर है
सर एक को बता देना सर,
एक बता देते हैं।
हाँ
तो ऑलरेडी तुम पार्शियल फ्रैक्शन किए हुए हो, फिर भी हम तुमको बता दे
हाँ
रहे हैं।
सर।
सपोज यू हैव टू फाइंड आउट द partial fraction of z into z plus 1 by z plus 0.2 into z plus 0.8. Okay, okay, so z को बाहर रख दो, बिकॉज जो हमारे पास इनवर्स z ट्रांसफॉर्म दिया हुआ है, वो हमारा जो स्टैंडर्ड फॉर्म रहता है वो a टू दी पावर k का z ट्रांसफॉर्म क्या होता है? a टू दी पावर k का z ट्रांसफॉर्म क्या होता है? e टू दी पावर k का z ट्रांसफॉर्म क्या होता है? z बाय z माइनस
Z-
k, z
Yes.
z बाय z माइनस
Z माइनस यस
सर। सो हमको यहाँ पे ऊपर में एनी टाइम z लाना है। हेलो,
यस सर।
तो जस्ट
Yes,
वेट
sir.
करो। सो z को निकाल दो, और यहाँ पर दो फैक्टर है, एक्चुअली करंट चला गया है तो इसलिए वो तुम्हारा कैमरा डिस्प्ले नहीं हो रहा है। तो तुम्हारा दो फैक्टर है, तो नाउ द z कॉमन लेके एक यहाँ पे रखो। तो ये हमारे पास क्या आएगा, आने दो, हम थोड़ा सा कर दे रहे हैं। k1 बाय z प्लस 0.2 प्लस k2 बाय z प्लस 0.8, यस और नो?
यस सर, सर समझ गए सर, मुझे जेड को बाहर रख के करना है ना।
हाँ,
Exact.
क्योंकि तो फाइनली तुमको स्टैंडर्ड फॉर्म में उसको रखना है तो z ट्रांसफॉर्म निकाल पाओ।
हाँ सर,
ओके,
हो जाएगा।
सो जस्ट वेट, 2 मिनट वेट करो।